Welcome once again to our cyclic geometry series. This is episode number 10, whereby we are going to be exploring the relationship between an angle formed between a tangent and a chord, together with the angle formed by the chord, or rather subtended by the chord. Let's go to our GeoGebra and then plot some stuff here. And that's it. We have a triangle inscribed in a circle, and then there is our tangent ABC. So we are interested in the relationship between angle ABE and angle BDE. Let's put in a protractor there just to measure those angles. The size of angle ABE is equals to 65.74 degrees. How about the angle, this one here, this angle here, EDB or BDE, that angle there. And this is it. That's the same values for the both of the two angles. Now let's try again with these other ones here. Angle CBD, was the value of angle CBD? 58.25 for angle CBD. How about angle BED? 58.25. Well, this is not a coincidence. As you can see, as I'm moving this, the angles are changing, but still the same. We have a chord here. We have a tangent. So there is an angle between a tangent and a chord is equals to the angle subtended by the chord. Now, let's just try to prove this theorem. Let's prove this theorem. Let's go to a proper working space. And then in this one, we are going to draw a circle. And then in our circle, we are going to draw a tangent. There you go. There is our tangent. Then let's draw a triangle inside this one. Now, there is our triangle. So, the theory is saying that the angle between a tangent, this is a tangent, this is a tangent, and this is a chord. So the angle between those two is equals to the angle subtended by this chord. So it's this angle. Those two are equal. Now we need to prove this one. We need to prove this one. Let's try to prove it. Don't forget we have a center of the circle here, like that. So to prove it, we are going to draw a line that passes through the center. We are drawing the diameter and then join it to the other one like that. And then we are going to do the proof. Let's put in some labels here: A, B, C, D, E, and then F. Now let's prove. We want to prove that this angle is equals to that one. Angle F is equals to angle ABD. Let's try to prove it. So to prove it, we just construct a diameter BE and then join point E to D like that. Let's call this one X. If this is X, let angle ABD be equals to X. Now from there, where do we go to? Angle ABE is equals to what? Remember our previous theories. That's 90 degrees. What's the reason? The reason is tangent is perpendicular to radius, or simply the tan rad. So if the whole of this, if this one it's 90 degrees, So this other part here, it's 90, take away x. So let's just write that one. Our angle DBE is equals to 90 degrees minus x. So we're just subtracting the x here, so we will be left with this one. So that's 90 minus x. Now let's check something here. What's the value of angle B? Angle BDE is equals to 90 degrees. What's the reason? Angle in a semicircle. It's 90 degrees. So if this is 90, what's the value of this one? Angle E. Let's try to write everything down. DBE plus angle BDE plus angle E. It's a long way. This is 180 degrees. Sum of the interior angles in a triangle. Next, DBE, that's 90 minus x. BDE, it's 90 plus angle E. This is equals to 180. 90 plus 90, it's 180 minus x plus E. Angle E is equals to 180. And then from there, let's subtract 180 from both sides of the equation. Minus 180 minus 180. So what does this gives us? This is going to cancel out with that, like that, like that. And then you are left with minus x plus E is equals to 0. Then let's subtract, or rather let's add x on both sides, plus x plus x. Then what does that do? On the left hand side, these guys are going to cancel out, and then you are left with A. So your angle E is equals to 0 plus x is x. So in other words, we are having an x here. We are having an x there, like that. But then what's happening between angle E and angle F? What's happening? They are angles in the same segment. Angles in the same segment are equal. Or rather, they are angles subtended by the same chord DB. So they are equal. If you are having a problem, just go back to our previous episode and then try to master each of the theorems, because we are just recalling angles in the same segment. That was our episode number 2. Now we are saying angle E is equals to angle F equals to x. Maybe let's not put that for now. What's the reason? Angles on the same segment, these ones, they are equal. So definitely, if this is x, it's equals to that. So your angle ABD is indeed equals to angle F, and then which is what we call our Chord theorem. What does the Chord theorem state? The Chord theorem or property, it says that the angle between a tangent and a chord is equal to the angle subtended, or rather arising subtended by the chord. Let's put in a drawing here. The angle between a tangent and the chord is equals to the angle subtended by the chord. Let's just draw. We have our circle there, and then we have our tangent, Remember, a tangent is nothing but a line that touches exactly at exactly one point. Then let's just draw the triangle there. There you go. So what is this thing saying? It is telling us that the angle between a tangent and a chord, the angle between a tangent and a chord, this angle here, this is a tangent, this is a chord. So this angle between these two guys, what's happening with it? It is equal. This one is equal to the angle subtended by the chord. So where is the chord now? This is the chord. What angle is arising from this chord? It's definitely this angle here. This one. It's this angle here. So we are saying the angle between tangent and chord is equals to the angle subtended by the chord. Same applies to this one here. Tangent, chord. Chord is subtending this one here. So these two angles are equal. That's the tan-chord theorem. Now let's go straight to examples on these theorems. Our examples will be ones that actually include not just the theory, but it's just a combination. Maybe let me put one example that will just require you to just apply the theorem alone. For our first basic example, let's try this one. We are required to find values of x and value of y. Just take a moment to start the diagram. Feel free to pause the video and then just try to answer the equations by yourselves. Then let's go ahead. Which one do we start with, x or y? Let's start with x. What's the value of x? Now, x is an angle between a tangent and a chord. X is between a tangent and a chord. Let's try to highlight those stuff here. This is the tangent and this is the chord. And then between those two there is x. Now, according to the tan-chord theorem, angle between a tangent and a chord is equal to the angle subtended by the chord. From this chord, the green one called BD, what angle is arising from the ends of this chord? Let's try to highlight it too. It's these two. Angle E, it's arising from chord, so it's being subtended by chord BD. So x is equal to 7 naught. X is equal to 70 degrees. Reason for this one, tan-chord theorem. And then you get all your marks for that one. Value of y. What is y? Now y is an angle in the triangle. Let's try to see from the other tangent, the other side. This is a tangent AB, and then chord BE. There is an angle 50 degrees. From chord BE, let me try to highlight again. Now, from this chord and this tangent, we have 50 degrees between those two. Then from this chord, what two lines are starting from the end of this one? It's this line and this line, and both lines are leading to angle D. So angle D is actually equals to 50 degrees because it's the tan-chord theorem. So this one is equals to 50 tan-chord theorem. Just like that. Now let's go to our real examples. Example 1. Now here is our example 1. Calculate the value of x. Clearly show you're working with appropriate reasons. So for cyclic geometry, your reasons should be clear, otherwise you will be rewarded 0 marks. You don't guess around here. Now we are required to find the value of x. Now let's first start with the theory of the day, Chord theorem. Where do we have an angle between a tangent and a chord? Yes, we have an angle of 50 degrees here. So let's just try to draw. Maybe let me use a different or rather bright color here. Now this one and this one, they are giving me this 50 degrees. So from this chord BC, what angle is formed from the ends of that chord? It's this angle here. This one, it's angle A. BAC. So basically, the measure of angle A there is just 50 degrees. There is just the Chord theorem. Just try to write that angle BAC is equals to 50 degrees. Reason, Chord theorem. Next, remember we are required to find the value of x. If this is 23 and the whole of this is 50, so our angle BAO plus angle OAC is equals to 50 degrees. There's no reason for that. That's angle BAC. So from there, what is BAO plus AOAC? That's 23. This is equals to 50. Then subtract 23 from both sides. And then this is going to give us, they are gone. Then we are left with BAO being equals to 50. Take down 23, that's 27. So we're having 27 degrees here. Now let's do this. Angle BAO is equal to angle ABO equals to 27. What's the reason for this one? This one's a base angles and isosceles triangle. Base angles of an isosceles triangle. Then from there, this is now telling us that if we use the sum of angles in a triangle, so this is 27 plus 27, giving me 54. Take it down from 180, you are going to get that angle there, AOB, is actually equals to 180. Take down 2 times 27. And this is going to give you 2 times 54. Then it's 60, 120 plus 6. It's actually 126. And then now angle ABO, angle AOB is actually equals to 2 times angle X. Angle at the center is twice the angle at the circumference. Angle at center is 2 times angle at circumference. Then your angle AOB, that's 126, is equals to 2 times X. If you divide both sides by 2, you are going to get that your X is equals to 63 degrees. Well, that was the first example. Remember the tan chord, angle between tangent and chord is equals to the angle subtended by the chord. Next example. For this example, something is missing here. Question. For this question, the statement was omitted. Now let's try to find the solution. If DCE is 44 degrees. If that's 44, work out the value of ACD. ACD we are required to find the value of this angle here. This one. What's the value of that angle? Let's go ahead and solve that. First things first, angle between tangent and a chord is equal to the angle A subtended by the chord. Now let's try to highlight. Tangent, it's this one. CE, it's our tangent. Chord, it's this one. So there is the angle. And then the two lines arising from the two ends of the chord, it's this one. So definitely it equals to this angle. Just write that down. So angle DCE is equals to angle DAC equals to 44. What's the reason for this one? And Chord Theorem. This is the Chord Theorem. Next, where do we go to? Let's put in the 44 here. Now we're also given angle B, and then this thing is a cyclic quadrilateral. We learned a theorem on cyclic quadrilateral. We said its opposite angles are going to give you a sum of 180 degrees. So 80 degrees plus angle D should give us 180. So there must be 100 here. Let's just write that one down. We are saying angle ABC plus angle ADC is equals to 180. What's the reason for this one? Opposite angles of a cyclic quadrilateral are supplementary. That is, they add up to 180 degrees. Now ABC, it's 80 degrees plus ADC, this is 180. If you subtract 180 from both sides, you are going to get that your ADC is equals to 100 degrees. Now you have this angle, you are looking for that. Let's just use sum of angles in triangle. So ACD plus the 44 degrees plus the 100 degrees should give us 180. Sum of angles in a triangle. Now this is ACD plus 44 plus 100, that's 144. This is giving me 180. Then subtracting 144 from both sides of the equation. Just remember, this thing called algebra works on balancing. What you do on the left, you must do on the right. So your ACD is equals to 180, take down 144. It's giving me a 36 degrees. So that's the value of the angle there. Well, that's the end of our lesson. We are going to do this example on the next video. Thank you for staying tuned.